All right, so now we want to dig into the details of the waterfall approach, each of those steps in the waterfall. My lecture here is based in a large part upon the book Applied Software Project Management by Stellman and Green. This was written in 2005. I really like this book. I think it does a really good job of sort of talking about software development, and it has a really reasonable approach to this classic style of software project management. And I would say it captures a lot of the good knowledge and understanding about where the industry was by that point in time in 2005, when they sort of wrote it just at the end of this era. There have been tons of books detailing the waterfall approach. You can basically, anything that you find written up about how to do software before 2005 is going to be talking about that and going to tell you all these ideas about how to run a good software project, and they're going to all fit within this classic notion of a waterfall approach. After this point in time, the agile methods started in the mid 1990s. Really were already starting to take firm hold at this stage, 2005, and of course by now I would say they're much more a dominant thing in the industry. So let's talk about what they tell us. And again, it's not a bad, horrible, awful process. You can still be successful, and you may still need to use this process in some ways, and we can still learn from this. And there's no reason not to adapt. And you might find that there's some things in this approach that you're like, well, I kind of wish we would do that on a project. You can do some of it. You just need to know the pros and cons. So the first thing is the interview. We've already talked about that in this course. It doesn't change. It's the same process, okay? As that what we've talked about before. Now, then you've got this vision and scope document. I actually think these documents are pretty useful. One of the reasons they're nice is they're not very long. The other reason is when you write things down, it means that you knew it well enough to write it down. If we just think about it in our head, we think we know things, but until we try to get it on paper, we're not sure that we know it. This is one of the reasons why I find, by the way, like studying for an exam, so really critical for me to actually write down new notes. Just reading notes doesn't prove to me that I know it. Actually, being able to restate my notes often shows to me that I can actually understand what's going on. So writing documents is often a good thing. Now, what's in a vision and scope document? So again, you're going to produce this after the initial client interview. What is the vision? So you're going to write this is often a paragraph long section or so, but it's really going to get at the goal of the project. And as well, talking about what is the problem, because that's what you went into that interview to figure out. Why does this client need us to solve this problem? You're also going to then talk about the scope aspects of it, and this largely is listing all the features with short descriptions about them, which should sound super similar to the idea of let's write stories. What are the features? Let's write descriptions of them. So in many ways, a vision and scope document is very similar to sitting down with your team and producing all the stories and organizing them that you're going to then put into your user story map. So it's but whereas this is typically done by a single person. So you're the business analyst, the information systems analyst, whatever it is, program manager. You might be doing this on your own, which of course has its downsides. I think there's a huge advantage, again, for everyone on the team to do this and start working on their shared understanding. Part of that will depend on the project and the team size. Again, we can't have a 100-person team show up for an interview very easily, nor work on this sort of thing. But if you're working with, again, on our 2-pizza team size, which is quite popular for getting sort of features done, this is quite applicable. You're also going to go ahead and put in the document things such as project risks. Now, this is not risks in the notion of risks to people and loss of life. This is risks to things like schedule and delivery and so forth and so on. What could prevent you immediately start in the plan and document world always thinking about what could delay and cause problems with this project. You're always trying to anticipate what's going to throw my plan off. Why might I not actually deliver the right thing? Why might I be late with what I'm going to deliver? What do I foresee as all these risks? And you start to, as a project manager, you're always working to be prepared to deal with those risks if they were to actually happen. You're also going to be working, you're likely to actually, for the features, you're going to have some sort of a release plan. So you might say, yes, release 1 covers these features, release 2 covers these features. And as well, you're going to be sure to put in this document what will not be delivered. We've talked about this before. This is very useful to make clear to a client, oh, I'm going to push this stuff off the plate. We're not going to be dealing with it. Oh, you thought we would? Okay, well, let's talk about that. Clearly we have a misunderstanding there. And then after you've written it, then it goes to review by the client. And the client tells you what you were right and wrong about. And once you've modified the document, adjusted it, and the client agrees that sort of captures the vision and scope, you move on to the next part of the project. And your next part of the project is to work on your project plan. All right. Now your project plan is, again, going to be a document or a collection of documents that together covers a whole bunch of stuff about saying what's the overall vision for how we're going to run our software project. In it, you're going to talk about who's going to do the work and what work is going to be done. This is often put in terms of a statement of work. You're also going to talk about any other resources needed. You might be needing equipment for testing. You might be needing data. You might be needing, how many people really are going to need besides just, the important members, impacts on other people in the company that, you're going to need. Then you're going to work with a team to come up with tasks and the time estimates for those tasks. All right. We'll talk about that in more detail. Then from that, then you create a schedule for all the work on the project. And again, you develop in more detail your risk plan, not risks to people's human life and so forth, but the risks that might push you off your schedule. So let's talk about estimation. So time estimates. In Scrum, we take each of our stories and we estimate it with story points. And we use then that mechanism and calibrate those story points to actual time by how many story points did we get per workday done. In the traditional waterfall approaches, they're not using story points, but there's no reason they couldn't use some notion of story points. I guess the biggest issue is they don't have a good way to calibrate the story points. They're not going to work in iterations and find out, oh yeah, it seems like we're able to get this many story points done per workday. So they were not going to know their velocity. So it's hard to employ them. So there's a general notion that you're probably always going to be estimating with time, which we know is a little problematic. But if you're going to do your estimates, you're going to use some sort of process to do this. Now you could have some sort of ad hoc process. Basically, you could ask people, how long is it going to take? And you could just even ask one person, well, how long is it going to take to make the schema for the database? Oh, I think it's going to take this amount of time. That's pretty ad hoc. Or you can use formal processes. And they talk about this in the book, such as they describe one called wideband Delphi. Now, the interesting thing, when you read about the details of how this wideband Delphi process works, it is extremely similar to what we do when we do sort of planning poker and other sort of estimation of story sizes. You bring a bunch of people into the room who are knowledgeable about software, would be working on the project and so forth. You have them try to estimate all the major portions to the project and the software, have them come up with their individual estimates, and then you show the people in the room, okay, you collected all those and you keep it all anonymous, but you say, oh, we have time estimates from here to there. Oh, we have some tasks that some people have and other people don't have, and you list these. And then you go and you ask them again, all right, now that you've seen all of that, please adjust your estimates. And they go and they change things and they have more discussions. And then they pass those things in and they show again, well, this is what we see in the room. This is how people are estimating. Well, that's a lot like what we're doing with, like planning poker. Let's talk about our story. Let's each vote on its size. Oh, do we all agree? Hey, we do all agree. Great. Oh, we don't. Well, let's talk about why you think it might be big and I think it might be small. So that's very interesting that we see the same sort of things. We can have both good practices and bad practices in either of these software development methodologies. It's not inherent to the waterfall approach to come up with lousy estimates for individual pieces of work. Not at all. It lacks the ability to sort of calibrate those estimates. So you estimate in time, which is faulty, but you can still use something where you use lots of opinions and you do lots of discussion to try to have this combination of experts, which is going to give you a better actual estimate than an individual person's time. One of the things that I used, so when I was in industry in this time period, one of the things that we experimented with for a while was we would do estimates in cave time. All right. So cave time, this is when you are in the flow, and basically the idea would be that developers can estimate time pretty well, but the time that they're actually estimating is that time when they are distraction free, they are really focused and able to concentrate on things, they feel like they're in the flow with writing the software, and so their estimates are when you're making time estimates, you say, oh, my time estimates these are my cave time estimates. And then what you do is you apply a tax rate to it. And so for a regular developer, it might be 1.2 times and 20% increase. For a team lead who has more interruptions from people and stuff, it might be 1.3. So you multiply them to then get your real-time estimate. One of the things that we do to help people learn to estimate better in this sort of world, though, is to keep track of how long are they actually spending on each task. Compare that to their original cave time and then their taxed increased time, and how far off are they? And so that they can learn to become better estimators. I often found that a 20 to 30% tax wasn't applicable. I needed about a 300% times tax. I was absolutely horrible at estimating in time. It usually took me 3 times longer to get things done than I thought it would take me to get done. So over time, I learned to be better at estimating through actually tracking my actual time and comparing it to what was being done. Scrum, again, automatically has a calibration methodology built into it. We don't need to hope that people learn to estimate better. Based upon how they're estimating, we're going to find out a general notion of how much work can be done within a given period of time. What about this schedule that you're supposed to do? Well, that's the other big thing in the project plan. So you start with estimating, you come up with all the tasks that you can envision. Usually we would say your tasks should be no longer than 2 days long. You'll note that that's different than what we're doing in 342. 342, I'm saying, your tasks should be about 1 hour to 2 hours, which on student time, working part-time, because you have all these other courses, it's about how much a task would take if it was to take you between 1 and 2 days. You'd put 1 hour of work in, you get it done in 1 day. So if you had a 2-hour task, you'd get it done in 2 days. And we do our stand-ups Monday, Wednesday, Friday. So the notion would be you should always be able to get 1 or 2 tasks done before the next stand-up, which is similar to the real world, that we would expect that for a lot of tasks where you're having stand-ups every single day, if most of your tasks are at most about a day long, oh, you'd be able to come back the next day and say, yeah, I got that task done. Oh, I'm ready to take another task. So we're not doing our task sizes the same in 342 as we would do in the workplace, but a lot of that has to do with the nature of our work. We can't expect you to put in an 8-hour day on your project every single day. That's not right. So but to get those benefits of tasks and tracking tasks and to estimate and so forth, we need your task size in 342 to be really small. Scheduling. Well, one way that people will schedule is, so you're going to go, one way to do this is to plan out your whole schedule of all those tasks with all of their dependencies. First, we have to do this, then we have to do this, and so far, so what. And then you also note out for each of those who is going to do that task. And then you're going to tack on some sort of buffer to the project. Buffer is typically noted should be about 20%. Again, we end up having to do all these inflations of estimates because we're planning everything out. There's actually every little uncertainty builds upon itself. We rarely underestimate. We rarely overestimate how long it's going to take. We usually are underestimating, so we have to have these buffers in place. So that's one way to do it, and you might find yourself making some sort of known as a Gantt chart. Very popular to see these in Microsoft Project and other sorts of project management tools. You'll spend forever making your Gantt chart, and then you run into a horrible issue, is that your chart and your plan, your schedule is out of date on day 1. Things take longer than expected, and so you must redo your schedule every day. to find out what's really going to be happening in this project and are you on time or not. You'll find that the software for dealing with these, the Gantt charts, are usually almost always massively inflexible and just are awful. And you'll never update that chart, or at least you won't past a couple days. And it'll be worthless tool for you. So one of the things is we end up with this waterfall approach that often people have inappropriate tools that they're going to use, and that contributes to part of the problem. We solve this in Scrum. We've got a nice Scrum board. We can see everything on that Scrum board. We see where all the tasks are, what's left to do, what's in progress. We can use a burn down chart to track our progress. We're minimizing our risks by only working for 1 to 2 weeks. I mean, we've learned from the mistakes made in the past. I'll tell you. Now, you'll see this in a lot of books, but there is actually an easier approach that's sort of halfway between a traditional, very controlled schedule and a agile one. I've used this approach, and it's actually pretty nice. So an easier approach is you go and we're going to assign the tasks to team members. All right. Each person, we're going to be sure that each person estimates their own tasks. Now you could do this as well up here. Okay, we'll get back to that. But let's say each person estimates their own tasks. And we see as we move usually more and more towards agile approaches that we've learned that we need to put more and more trust and faith and control in the individual experts, individual professionals working on our teams, and less of a sort of a command and control. Anyways, we go ahead and we assign the tasks to team members, or you could have a notion of self-assignment, but usually these are tasks for these people and so forth, and you might be all in a room divvying things up. You could do it together, but then once you know which tasks you're going to do, you estimate times against all of them. This is for the entire project. And then so each person gets a stack of tasks. All right. And the idea would be, so one person's got this stack, another person's got this stack, another person's got this stack, another person's got a stack like this, and so forth. And what you do as a project coordinator is, so this stack, this height of the stack, this is how many tasks they have, as well as the truth is you sum up from top to bottom is the total amount of time. That's what really the height of the stack represents. Is if this person worked from now through all their tasks, what do we currently estimate their total time to be? And so when you look across a team working on stuff, you just basically, you find what is the tallest stack, and that amount of time then is the time till the project is done. Okay, and so these tasks are ordered such that if there are dependent tasks, the ones that have to be done first are on the top of the stack. We try to minimize dependencies across people, but even so, as long as we're kind of working down them, that's okay. And what we do as a project manager as we look at this was see, oh my goodness, this person's got way too much stuff done. And we're going to be late on the project now because this is going to take too long. So, they ran into some mistake or problem. So what we do is then we start pulling tasks out and redistribute them to the other stacks. And you can see that this is actually a little bit similar to what we try to do with our Scrum board. Rather than pre-assign things in the Scrum board to people, what we're going to do is not pre-assign them, but as people become available, they take those tasks and they do them. And so we naturally load balance, and we basically end up with getting the work done in an optimal fashion time-wise. So whatever actually happens in Scrum is as good as it could have happened. We didn't need to plan it out that one person would work on one thing or another in advance. Now, this might be a little bit more comforting to you to know, oh, these are all the things I need to do and I'm going to work through them. But at the same time, we always keep in mind that, yes, we're going to, you're falling behind schedule. We're going to move your tasks, some of the other tasks to other people so that we can load balance the work again. Yeah, so that's the first part of Waterfall. Definitely some similarities, some differences. Continue with Waterfall in a moment.